So today we're on this 2007 Nissan Sentra looking at the PCV system, and over here we have the fresh air side that goes into the intake before the throttle body, and this big box right here has a little foam filter inside of it so the air going in isn't all oily and dirty. And then on this side you can see right here on the side of the valve cover is the actual PCV valve, and then this hose runs all the way back here into the back of the intake manifold, and that's where it gets the vacuum from right after the throttle body. And now we're gonna test the whole system and make sure it's all good.
So now we're gonna test the PCV valve. We disconnected this hose right here, and we're gonna grab a socket, take this PCV valve out and shake it to see if it's good and freed up. So right here we have a diagram of all the conditions that it could be in. The blow-by comes from this way and the vacuum is from this side. And when we push the plunger right here with a screwdriver, it went in, but it didn't come out. So that means that the spring's not working. So under acceleration, it won't have enough force to push the spring, or the spring won't have enough force to push it. So it'll be like idling at acceleration. So now we're on this 2019 Honda Civic. The PCV valve is integrated into the valve cover right here. And Mr. Heisner said that turbocharged vehicles, for the wastegate, instead of just venting it into the atmosphere, right here we have a tube that goes all along right here into the manifold right here. Here on All Data we have my car's diagram. It is the turbocharged version, and you can see all these hoses. There's all these additional hoses because of the turbo. And right here we have the 2-liter non-turbo, and there's way less hoses than for the turbocharged one.
So we're on this 2007 Mini Cooper, and it has an aftermarket oil catch can installed right here instead of a typical PCV system. And it works in the same way, except it keeps the oil from going back into the intake. So here we have an EGR that is vacuum operated, but it has an EGR position sensor on it, and we're hooked up between the two pins on the position sensor. And as we move the EGR valve, you can see the resistance changing. And here it is about fully open, about 3,000 ohms. And when it's closed, it's about 900 ohms.
Hi guys, we're on this 2001 Buick LeSabre doing an EGR test. Here's the connector for the EGR valve. We are going to be back probing pin C, which is the signal wire. Right here we have it back probed and grounded. And right now it is off and it's showing 0.8 volts. And right here on the scan tool, we're able to adjust the percentage. And right here, now instead of 0.8 volts, it's at 1.2 volts.
So we have the scan tool pulled up here, and we have the EGR percent control up on the scan tool. And we can use the plus and minus to control the different percents of EGR opening. So we're going to start the car and see what it does at idle with different percents. So at idle with 0%, the car's running fine, but as we open the EGR more and more, you can see the engine start to bog down a little bit. Our RPM gauge doesn't work on this car, so we can't look at that. It's just 0 all the time. But you can definitely tell from in the car it's vibrating a lot, and the more you open the EGR, you can tell it start to bog down and shake more and more.
So now we're going to increase the duty cycle of the EGR valve, and we're going to see the readings right here. We're increasing it by 10% every time.